Dear students, welcome to the lecture of physical database design and tuning. In this chapter, we are going to discuss all the factors that influence the performance by a good design and tuning. If the database design is not taken care of, then the performance of the database can go slower. And hence, with the case of tuning, if the tuning of indexes, if the tuning of the different parameters related to the database is not taken care, it can make the database performance go slower. Now, let us see what are the factors that influence the design and tuning process. The agenda of our discussion today is to list and discuss the different factors that influences the physical database design in the relational databases. We will also see the design issues, the database design issues, and the decisions made. In general, there are 5 factors that influences the physical database design, which talks about the database queries, expected frequency of calling these queries, the time constraint related with the queries and the transaction, the frequency of update operations, and the uniqueness constraint on the attributes. These are the factors that influences the database design. Hence, analyzing them and taking the best of the solution is the first thing that we are going to see in factors. So let us see the first factor that influences the physical database design in the relational database, which is called as analyzing the database queries and the transactions. Let me check if the screen is being shared. Yes. So the first thing what we do is we analyze the database with respect to the queries and the transactions that it is running. How do we do that? Let's see. For each query, we need certain important information. That includes the file in which the query, one second, please. Yeah. Okay. So for each query, we need some important information. For example, the file that is being accessed by the query, the attributes of the query on which the selection condition of the query is specified. We also need to know the attributes of the query on which any join condition or conditions of multiple tables are linked together, or objects for the query are specified. We also need to know the attributes whose values will be retrieved by the query. So these are the 4 important information about the query that we must know, which will help us to analyze the database when the database is trying to run the query. It quickly have to check the file that the query is referencing to, the attributes on which the query is trying to select the records from the database, the attributes on which the query attributes or you're writing a query whose attributes, on which attributes the join condition or the condition which is helping you to link many objects or the tables together are specified. Similarly, we also have to know that what values the query is trying to retrieve. For example, if I say select star from the students whose GPA is greater than 3 or GPA is greater than 4, for example, or GPA is equal to 4. So I must know what values it is going to bring. Okay. And if I say, get me the information about the exams on the year 2021. So here we have, all the names of the courses in the final exam that were held in 2021. I will have to join the course table plus the exam table to get the results. So the query here in this example is trying to join the exam table and the courses table and then trying to give me. So the database needs to analyze the tables that are being joined with respect to the query and its attributes, the values that are going to be returned by the query, the attributes on which the select condition is returned, and the file that is being accessed by the query. For each query, this information is needed. Now let us see the important point. The attribute, the list item 2 and 3. What are they? The attributes on which the selection condition is there and on which the join condition is there. They become the candidates. Candidates means they become the choice for defining the access structure. Now I will quickly revise what is an access structure. Access path, it is like an index, right? Access path is an index. So it helps us to make an index. Okay, it's like it's trying to become an access structure, that the way how we are going to access the data from more than one table at a time. So this was all about analyzing the database queries and the transaction. So this is the first factor that the database have to analyze in order to make the physical database design. The second factor that is talking about the expected frequency of calling. Invocation is nothing but calling. The expected frequency of calling the queries and the transaction. For example, if we use banner in the week 1 2 3 4 5 6 7 8 week of giving the lectures, what is the expected frequency of calling an attendance query? Maybe 5 times a day, maybe 4 times a day. For if there are 4 courses to run in the schedule for Sunday, then the query frequency here will be calling out the attendance query 4 times a day. Okay, so why is it that needed? Let us see. The expected frequency information along with the attribute information is collected on each query and transaction. Yeah, we know that we need to know a particular query or a transaction is called how many times in a given span of time. It is used to compile a cumulative list. Okay, cumulative list is like for example, the attendance query is called 4 times on Sunday, 5 times on Monday, okay, 2 times on Sunday. Now the cumulative is like addition, 4 plus 5 plus 2. Okay, so a cumulative is used. A cumulative list of expected frequency is used and it is compiled for all the transactions and the queries. Okay, now it is expressed as now why do we use it? It is expected that the frequency of each attribute in each file as a selection attribute or a join attribute for overall queries and transactions. So for example, here we are trying to call the query related to attendance maybe 4 times on Sunday. Okay, so we are here the attribute for each query, the attribute for each query here could be the day of the week. Okay, so that will be used as the way of selecting the file based on attribute selection or the join attribute for all the queries and the transactions. Okay, now the rule, the DBMS follows the rule of 80-20. What does it mean? It means 20% of data is accessed 80% of the time. So the only the 20% part of the DBMS or the database is accessed, or not DBMS, the 20% of data is accessed most of the time. For example, from the banner, we are not accessing, upgrading the grades or uploading the grades all the time. We are just using attendance on each day basis, right? So if you visualize the database of banner, then the banner part which is related to attendance, it's only 20%, and then the remaining is calculating the scores, inputting the scores, and then for example, we have course registration. There are so many other features of the banner that are not accessed. You just access registering and dropping the course once in the semester. We upload the grades, final grades once in the semester, but what are we using on daily basis is the attendance. So it is said that the only 20% of the database is used 80% of the time. Did we get the point? So this is this tells like how frequently we call the queries and the transactions.